Hi guys, welcome to today's lesson. So we're going to be focusing on solving exponential equations, right? But before that, remember we're going to map out what we're going to look at, and then at a later stage we'll then look at some examples that have to do with everything that we're going to talk about today. So remember that firstly, to map out our concept of exponents, there's what we call the laws, which you've really been doing from the early grades and all of that. And then now we're going to introduce what we call rational exponents. And then we're going to have radicals, which are the same as surds. But for now, I'm mainly going to be looking at the concept of equations, right? And those equations will include some rational exponents there for us to look at. Now, the keywords for us, remember, is the prime base. I know that prime numbers is something you're familiar with, but now we're going to change our bases and write them as prime numbers, right? And then also there's what we call the reciprocal. Remember, a reciprocal will be more like you tipping and timesing a fraction. So if I have A over B, the reciprocal of this will therefore be B over A, right? So we're going to be talking about the concept of a reciprocal in this lesson. Now, when you talk about an exponential equation, this will be an equation in which the variable is the exponent, right? So if I have x squared, that has nothing to do with exponential equations or expression. It's just a term that has an exponent of 2. But as soon as the x is then the exponent itself, we then call it the exponential equation. So as you can see here, 2 to the exponent of x, that x of mine is the variable, and it becomes an equation because of the equal sign, because remember, equation is a relationship between two things, which we normally show using an equal sign. Now, when we are solving exponential equations, the very first thing, the same with expressions, the same with all the concepts of exponents, you are to make sure that all the bases are the same by doing what? You are rewriting them as prime bases, right? So the important thing here is to make sure that they are prime numbers. So for example, if I have something like, let's say maybe I have 4, right, squared. This is the same as 2 to the exponent of 4, agreed? Now, if I give you something like 64, I know that 64 is the same as 8 squared, but 8 is not a prime number. So I can just go straight to a prime number by saying this is just the same as 2 to the exponent of 6 there. That's what 64 is, right? So that's one of the things that I just mean when I mean make sure that you rewrite the bases as prime bases. If you leave it as 8 and then go there, they will be like that additional step that you will need to do, which is kind of a lot of work. But for you to understand this, you're practicing, start there until you are used to rewriting certain terms in exponential form. Now, let's look at the previous example that we were looking at, which is 2 to the exponent of x is equals to 16. This is the same as 2 to the exponent of x, which is the same, which is equal to rather 2 to the exponent of 4. What did I do? I just rewrote the 16 in the form of 2 to the exponent of 4 using the base that is a prime number, right? Now, that is the prime base as I've just told you now. And then the second thing that you need to make sure you do here will therefore be to use the laws of exponents to do what? To simplify both the sides of the equation to a single power with the same prime base. Now the goal here is to make sure that if I have a lot of bases, right, on one side multiplied together, added together and all of that, and on one side again multiplied, divided and all of that, the goal is to make sure that I have one power, meaning 2 to the exponent of it doesn't matter what is there, equal to 2 to the exponent of it doesn't matter what is there. But the important thing are the two 2's that I have as my bases. And that's the goal. That is what we are trying to do after converting them to be in exponential form. So this step says what? Simplify one side, simplify the other side, such that you have one power with the same base. Remember, I said the word power does not necessarily mean exponent in this concept. It means the whole base with its own exponent. The whole thing, we call it a power. So please make sure you do understand that. Now, just an example for this, it will be 9 to the exponent of x minus 1. So to simplify this, I must change everything to be the base of 3, right? Or a prime number. So this is going to be 3 squared into x minus 1. And this is equals to 3 cubed into x, right? Then multiplied by 3 to the exponent of x plus 2. And then what do you do? This will then give me 3 to the exponent of 2x minus 2 equals to 3 to the exponent of 3x. Because the bases are the same, I will just add the exponents plus x plus 2, right? And then the last step now will be, when those bases are the same, you can now equate the exponents, right? You can equate the exponents by doing what? By getting rid of the bases and just leaving the exponents as is. That's what equate means. So let's look at the previous example. Remember, it was 3 to the exponent of 2x minus 2 equal to 3 to the exponent of 4x plus 2. What this is, you're going to get rid of that base and that base there, meaning you will equate your exponents, right? Equals to 4x plus 2. So the law here is, when the bases are the same, definitely the exponents need to be the same. If you solve this using your normal algebra, it will be 2x minus 4x is equals to 2 plus 2, which is negative 2x equals to 4, and then I will have x is equals to negative 2 as my final answer there. And that's what you will therefore need to do there. So please remember, the main thing, make the bases the same. If the bases are the same, make sure that you simplify them such that you have one power. And then after that, lastly, you then equate your exponents, provided that those two powers you have on either side have the same base. If they don't have the same base, you don't do anything of that sort. I'm not dividing bases or anything like that. No, I'm just equating the exponents, because the law says if my bases are the same, consequently my exponents therefore need to be equal as well. Guys, for now, I know I've kind of shared a lot so far, but I want you to just stretch a bit so that when you come back to